Okay, in this video we're going to look at the link between moles and chemical equations, and the type of calculations that you'll come across in this section will enable you to work out how much reactant or product is formed or needed given the mass of one other substance. Now the key to this is a balanced chemical equation. 99% of the time this will be given in the question. So all you need to understand is that this means 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. So the big numbers in front, where they're there, mean numbers of moles. And of course, we never write 1 in a balanced chemical equation. Just seeing CH4 means we've got 1 lot of that substance, or now 1 mole of that substance. So if you can do this sort of thing, it's pretty easy, then you can pick up some marks on these otherwise quite tricky questions. We're going to look through some worked examples now. And the first example, here's the question. Okay, you can see the chemical equation is given to you. The question says, what mass of calcium oxide can be obtained from 500 grams of calcium carbonate? The first step is to write down the number of moles of the substances in the chemical equation. Now we're not bothered in carbon dioxide because it's not in the question. We're not bothered with carbon dioxide, it's not in the question. So we just want moles of calcium carbonate and moles of calcium oxide. No number in front, so it means 1 mole, 1 mole. Now, you should all know how to convert a mole to masses. It was the last thing you did. So what I want you to do is work out the mass of 1 mole of calcium carbonate and the mass of 1 mole of calcium oxide. So please pause the video now while you do that. So to work out the mass of 1 mole of calcium carbonate, you look up the ARs of the substance. 40 plus 12 plus 3 times 16 for the oxygen. And then the same on the other side, 40 plus 16. And my maths makes that 100 grams of calcium carbonate gives 56 grams of calcium oxide. You've then got to answer the question. That's the final bit. Now some of you might think straight away, okay, I can do that in my head. I know 100 grams, if I had 100 grams of calcium carbonate, would give 56 grams. So 500 grams would give 5 times as much. And if you can do that, that's fine. But if you can't do that, and the ratios might not always be as nice and simple as the ones I've given you here, then here's a solution. The first thing to do is find out what 1 gram of calcium carbonate would form. And that's done by dividing each side of this equation, the masses in it, by 100. So 1 gram, 100 over 100 gives 1 gram, 56 over 100 gives, well, we don't know, we don't need to work it out. Now we haven't got 1 gram, we've got 500 grams. So to find out what 500 grams would give compared to 1 gram, we simply multiply by 500. 500 is 500 times bigger than 1 gram. And then we just need to do that little sum there. Here's the 100 just carrying through from the line above. If you do that sum, you get 280 grams of calcium oxide. Don't forget, you can pause this video at any time and just go back and see that bits and pieces make sense. So let's look at a second worked example and see how we get on with that. Okay, in worked example 2, we're taking 4.8 grams of magnesium and seeing how much magnesium oxide we can make from it. So let's have a look. Here's the equation given for you, and you should be able to write down the number of moles of the substances in the question using that chemical equation. Again, just pause the video while you do that. So you should have written 2 moles of magnesium form 2 moles of magnesium oxide. Then your next step is to convert those to masses. Again, pause the video while you try to do that. Okay, stop it now. Okay, so to do that, 2 times the AR of magnesium goes on to form 2 times the AR of magnesium plus the AR of oxygen for magnesium oxide. Do the sums, and I get 48 and 80. Again, this is the stage where you might be able to think, oh yeah, 48, 80, so 4.8, yes, I can work out what that will give. But again, here's the fail-safe way. 1 gram will give 40 over 48. I've divided each side of the equation by 48. So 4.8 grams would give 80 times 4.8. So 4.8 times more than 1 gram, again divided by that 48. So you can have a look and work that out and check my maths, but I get that as 8 grams of magnesium oxide. Okay, here is worked example number 3. And again, there's the question, and there is the balanced chemical equation given to you. What I want you to do is try to go through the 3 steps without any help now. So pause the video please, and then try and go through each of the 3 steps. So how did you get on? Well, the first step's easy, isn't it? We're interested in aluminium and aluminium oxide in the question. So there's the aluminium, there's the aluminium oxide. So 2 moles of aluminium oxide forms 4 moles of aluminium. Okay, 1 mark, straightforward. Step 2, converting to masses. Okay, now if you didn't get this step right, you might want to pause the video now so that you can actually try this convert to masses bit. But anyway, here we go. Here's what it should look like. 2 times 27 for the aluminium, plus 3 times that should say 16. That's a typing error, apologies for that. For the oxygen, and times 2 because of the 2 in front. 4 times 27 for the aluminium. Do the sums. I've got the right answer despite my incorrect working. That is 204 grams. Gives 108 grams of aluminium. Again, you might be able to see, oh yeah, 20.4, it's going to give me 10.8. But if you can't, then here's the way to do it. Again, divide each side of the equation by the number that's here. So that's 204 divided by 204, which gives 1. 108 divided by 204. We don't need to work out what that comes to. And then we haven't got 1, we've got 20.4, which is 20.4 times bigger than that sum. And so we should get, I hope, the answer of 10.8 grams. Okay, please feel free to watch that video 2, 3 times, however many times it takes for you to see where all the various numbers come from. What I'd then like you to do is go on to the hot potatoes exercise called Calculations from Equations. That will just give you an opportunity to practice this sort of idea. The hot potatoes exercise sets it out nice and neatly, and you just have to do the various bits of working as illustrated on here. And it's an opportunity for you to make mistakes. It doesn't matter. And then I will give you a worksheet on these, possibly when we're back in school, some of us.